Good. So yeah. Second questions we want in the indices is 9 raised to power 1 minus x onto 27 raised to power y, and x minus y is equal to 1 whole number minus 1 over 1 over 2. If we are to solve this, as I've explained early, that if you have to use the same pattern again. How does it look? 9, the same thing is the same thing as 3 times 3, which is 3 square, and 27 is 3 times 3 times 3, which is 3 raised to power 3. So for any question now, if you are this one now, it is therefore, if you want to solve this, since 9 is 3 square, the same applicable to now have 3 squared onto 1 minus x is equal to 3 raised to power 3 multiplied by y. From the first example I did in the first live class is that, as I've said earlier, that the base are equal. Since the base are equal, meaning that 2 onto 1 minus x is equal to 3y, which is 2 minus 2x is equal to 3y. How do you do this? You now say that 2 is equal to 3y minus plus 2x. So you can now say that 2x plus 3y is equal to 2. Now, if 2x plus 3y is equal to 2, that is, recall that the question given to us, you can call this one equation 1, you call this equation 2. So if you call this equation 1 and you call this equation 2, means that this will be equation 3. So how do you got equation 3 for those are just joining? How do you got equation 3? So the equation 3 is being gotten by analyzing, because 9 is 3 times 3, which is 3 square. And the 27 is 3 times 3 times 3, which is 3 raised to power 3. So, therefore, 3, by the time you're able to apply some laws, which I've explained from the first example, that since they have the same base, which is 3 and 3, and we call this topic indicical equation. Since they have the same base, automatically you now say 2, the index will be equal. That's all. So since the index are equal, making 2 times 1, 2. 2 times x minus 2x, 3y. So you now try to collect like times. What do you mean by like times is the one that have variable and the one that are constant. What are the ones that are constant? Y 2 is constant. The x and y are the one that have a variable. So you put them in the same place, which is 2x plus 3y is equal to 2. So therefore, this is equation 3. We will be given equation 2, which is x minus y. X minus y is equal to, which is minus 1.5. Minus 1.5. So you try to rewrite it better to be 2 times 1. 2 times 1, that is 2. So 2 times making plus 1, making minus 3 over 2. So to make it linear, and anytime you are doing this, you try to make it linear. Let's multiply all through by 2. We have 2x minus 2y is equal to minus 3. So let's call this equation 4. Let's now combine equation 3 and 4. So if you want to combine equation 3 and 4, the equation, this is 2x plus 3y. This is 2x plus 3y. 2x plus 3y is equal to 2. Is equal to 2. So the equation 4 is 2x minus 2y is method. If you're able to see, we have 2x. So the both 2x, what you just have to do is let's subtract. Let's subtract equation 2 from equation 3. So therefore, in the presence of 2x minus 2x will give you 0. So 3x minus the meaning is just 3y minus 2y is equal to 2 minus 3. So therefore, it will be 3y plus 2y is equal to 2 plus 3, making 5y is equal to 5. So y is equal to 5 over 5. So this is just how, so which is y is equal to 1. And you cannot use any of the equations to find the value of x. So let's use equation 3, equation 4, 2x minus 2y. He said 2x minus 2y is equal to minus 3. This is where we arrive. And we're able to get y to be 1. So making 2x minus 2 on 2 is equal to minus 3. So 2x minus 2 is equal to minus 3. So 2x is equal to minus 3 plus 2, making 2x is equal to minus 1. So x is equal to minus 1 over 2. So I would like this class tomorrow. I'm happy for those that join.